So let's do a final example here. So this is going to be example number 4. We will let our function f of x, y, z equal some trigonometric function this time, x z times the cosine of x, y. So that's going to be the function that we want to integrate. And we want to find the integral of f over the region bounded by y equals the sine of x, y equals 2 sine of x, x squared plus y squared plus z squared equals 4, and z greater than, not greater than or equal to, and z less than or equal to 0. Okay, so these are our boundaries. Y equals sine x, y equals 2 sine x, x squared plus y squared plus z squared equals 4, and z is greater than or equal to 0. Okay, so we're going to have everything below the the xy plane, because z is going to be negative. So let's go ahead and deal with the xy plane first. So let's just see what this looks like. So we have y equals sine x, so that's going to be that graph right there. Y equals 2 sine x, that's going to be that graph right there. Sorry, my hand is a little shaky there, but you know what the graph looks like. So it looks like x is going to run from, x is going to run from 0 to pi, from here to here, because we're looking at this region in the xy plane. Z is less than 0, so it's going to be everything below this plane. And x squared plus y squared plus z squared equals 4. That is the sphere of radius 2. So that's what you've got. So now let me draw this in 3 dimensions as well as I can. It's kind of difficult. And again, you don't necessarily need to see it. If you have all this information, if you have the kind of a mind that can sort of pick out what's going where, you don't need to draw it out. So remember, this is, crazy lines again. I love those things. Okay, so this is x, this is y, this is z. So y equals x, so we have, that's sine x, that's sine 2x, so this is the region. And then of course we have everything below that, so we have the sphere. It's a little weird, I know. You know what, I'm not doing a very good job drawing it, but you know what's happening. It's basically this region, everything below the xy plane touching the sphere x squared plus y squared plus z squared equals 4. So, okay, so now let's go ahead and recall what's going where. So x, we said, is moving from 0 all the way to pi. Well, y is moving from sine x to 2 sine x. So sine x to 2 sine x. That's lower and upper. And z, well, z is going from minus radical 4 minus x squared minus y squared up to 0, right? The lower limit of integration is the actual sphere itself, and it's going up to 0 because it's below the xy plane. So this is what's important. So now our integral is going to equal the integral from 0 to pi the integral from, oops, not 0, the integral from sine of x to sine of 2x, and the integral from minus radical 4 minus x squared minus y squared up to 0. And then, of course, we have our function, which is xz cosine xy. And again, this is x, this is y, this is z. So we're working out. So we're going to do dz, dy, and dx. And when we put this in our software, we get the following number, 13.657. Again, perfectly valid number. So when you're doing these integrals, this is what you want. You want to be able to construct the integral. You want to be able to, you're going to integrate along x, you're going to integrate along y, and then you're going to integrate along z, or I'm sorry, x, y, and z. Three things. You need to be able to put, you need to be able to choose these things. That's what's important. The rest is just integration. Okay, so that is our introduction to triple integrals. In the next couple of lessons, we're going to be talking about cylindrical coordinates and spherical coordinates and triple integrals in those particular coordinate systems. Thank you so much for joining us here at Educator.com. We'll see you next time. Bye-bye.